By this point, you know LLMs are models that run on computers. In the last video, we talked about open source versus closed source. In this video, we're going to talk about where that model runs, if it's on your computer or in a server, and what the size of the model or the age of the model means for that model, its capabilities, and ultimately its performance. So when we think about our different models, we can think of models have different ages and models have different sizes. Let's dive in. Looking at this list, we can see that we have some old models and we have some new models. But what does that really mean? Well, new models are generally larger, meaning they have more parameters. They generally have better understanding and generally are more capable, whether that's coding capabilities, agentic capabilities, reasoning capabilities, and beyond. If we look at a plot of the evolution of large language model parameter sizes over time, we can see the first large language models were around GPT-2. Okay? GPT-2 has 1.5 billion parameters. Well, what does that mean? Well, if you go to Hugging Face, which is a site that contains the source code of several models, you can go interact with GPT-2. So GPT-2 has 1.5 billion parameters, and you can check out this repository and try one of the examples. So if you click on try one of these examples, it will pull up some text that will then be used to feed GPT-2. And just for simplicity, you can hit tab, enter, tab, enter, tab, enter. And this is the way to accept and select and accept and select and accept and select through the GPT-2 model. You can see a couple of things. First, these models are terrible. It feels like we are in the Stone Age of LLMs with GPT-2. So again, remember, GPT-2 has 1.5 billion parameters. Parameters are what make a model big. You can see on the scale here, GPT-2 has 1.5 billion parameters. GPT-3 has 5 billion parameters, and so on. Now, GPT-4 and beyond only have rumored or predicted number of parameters because there was a movement in the field to stop publishing the number of parameters of your model. Well, what do I mean when I say parameters? Language models work essentially by mimicking the connections in human brain. We have an input layer. An input layer is essentially going to be the text prompt that you put into the model. Then we have a lot of processing layers or hidden layers, and ultimately an output layer, which is where the AI model generates a response based on all of the patterns that it found. All of the magic happens in this processing layer or these hidden layers. Essentially, the parameters that I was talking about are the connections between layers. These are like the synapses in the brain, the connections between the neurons. More parameters essentially means more patterns the model can recognize. So like I said, GPT-2 had 1.5 billion parameters. GPT-3, 1 year later, had 175 billion parameters. And GPT-4, again, rumored, over 1 trillion parameters. But the bottom line for you here is bigger models equal more connections equals a better understanding of language. So that's why we see the evolution of these model parameter sizes to continually increase, because the increase in the number of parameters increases the capabilities because of the patterns that these models can find. Now, if we look at Meta, for example, and these Llama open source models where we know exactly how many parameters they are, they're open source after all, we can see a unique thing happening. So first, we see this predicted, expected increase in the number of parameters. But look at the red box here. We also see something interesting. We have the Llama flagship model, but then we have some other models that are smaller. Well, what's going on here? The models also have small and large versions available. Well, how does this work? We have a trend that's happening today where we have smaller, smarter models. So why go small? Well, big models are expensive and slow to run. And we certainly have all heard about the cost, the environmental cost, the energetic cost of running these models. They need powerful computers to run on. And importantly, we can't use these large models on phones or personal devices. So there's an effort to try to take these flagship models and make them smaller. Generally, this is going to happen through 3 different approaches. The first is going to be something called knowledge distillation, where a large model is going to teach a smaller model, like an expert training an apprentice. It really keeps the most important knowledge, but perhaps drops some of the rest. There's also pruning. Pruning is going to remove unnecessary connections. Remember, these parameters are the connections between the layers. So it's like trimming a tree, keeping it small and healthy, so the model stays small and smart, but runs faster. And then also there's this effort to do something called quantization. This is going to be using simpler math inside of the model, like using round numbers instead of decimals, like a smaller file size that has really small, minimal quality loss. So you take all of these together, and what do you end up with? Well, you end up with something like Llama 3.2, which has a 2 billion parameter model, which is the screenshot that I showed you earlier that I downloaded onto my computer. So again, Llama 3.2 can run locally on my computer. Now, the 1 billion parameter model can run on phones. So it's pretty amazing to consider having a large language model that runs directly on your smartphone. Gemini from Google has a model called Nano that works offline and on devices. And generally, compared to flagship models, these are 10 to 100 times smaller. And mostly, they're going to be 90 to maybe even 95% capable. So let's step back for a second. I told you that as we end up increasing the number of parameters, we increase the capabilities. Well, what we want to do is we want to try to then figure out how to keep these capabilities and prune out all the things that we don't need. So in this way, we end up with smaller models, which really means that AI models can be everywhere, not just in data centers. So ultimately, we think about LLMs are models that run on computers. And if they run on a smartphone, a small computer, if they run on your laptop, a medium-sized computer, or they run in a data center, a arguably large computer, then you can end up with different sized models tuned for that compute power. So now, when we look at this choice of the different models, we can see we've got old versus new. Llama 3.3 is old, Llama 4 is new. We've got Maverick, which is the base model, compared to Scout, which is the smaller model. We can also see, again, we've got some open source and closed source providers. So that's the second key for this series, which is size finds patterns and should be chosen for the task at hand. So remember, newer models have more parameters. Large models have more parameters and can find more patterns between words. And small models can run on devices.